So this is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class for your own security reasons. So you should be in the January 18th ticket. All right, so the link is in the chat box along with the password of the day. So make sure you get that all set and ready to go. Awesome. Hi, Zoe. Looking good. Hi, Adrian and Kyrie and Ty. Hi, Jasmine. Let me know how you're doing today. Awesome, guys. So make sure you get that open. Get me your green checks. Still waiting on a few more green checks, letting me know you've got that ready to go. So Angelina, Diego, Edgar, Elijah, Gabriel, R, Jackie, Jeremy, Joshua, Juliana. Thank you, Juliana. Kyrie, Kim, Vega, Siva, Ty, Zoe. Make sure you get your green checks. Oh, here we go, Kim. For your ticket, just letting me know you've got it ready to go. Want to make sure it works for everyone. Awesome, guys. Okay, so we only have 3 days left of the quarter. Count them up. So that means next week you have Tuesday, Wednesday, Thursday. You obviously have the weekend, so you do have a 3-day weekend. So technically, in terms of like actual days, you technically, I think, have 6 days, right? So you can use your 3 days over the weekend to catch up on anything that you need to. Highly recommend doing that, especially if you haven't done the last lab. I know I haven't submitted the grades yet. So those grades will be in today. You'll notice that most of your extra credit is in there as well. So the grades should be pretty finalized by tonight. So you want to take a look at those grades, make sure over the weekend that anything that you're missing, make sure you get caught up on. Okay, guys? Smiley faces if that makes sense. Smiley faces if that makes sense. Looking good. Awesome. Thank you, guys. Okay, so today is Friday. We're doing our final exam, part number 1. So if you take a look at our calendar, again, I just want to remind you guys that today we're doing part 1 of the exam. Monday, there's no school because of Martin Luther King Day. Tuesday, we are doing part 2 of the exam, and then Wednesday and Thursday, you kind of have to yourself, right? Remember that if you're done with everything, just make sure you log in on these days to get your attendance credit. But if you do have stuff to do, you can obviously use these days and catch up on anything that you need to do personally to make sure that you pass your classes. Remember, you can still turn things in late and still get full credit. You can retry things up to 5 times. That's true for pretty much any class. So unless you have a really specific thing going on in a certain class, pretty much every class you can turn things in late and still get full credit, and you have a lot of attempts that you can do on each assignment. Thumbs up if you understand, thumbs down if you're confused. Annalise, yes, the exam will affect your grade. So today's exam, I believe, is 10% of your grade, and then Tuesday's exam is 5% of your grade. So in total, the exam is 15% of your grade. So you do want to make sure that you do really well on it. Altogether, the final exam is the largest grade in the entire course. So far we've had the midterm, which was the biggest grade, but now the final exam will actually be even larger. Okay, so we really want to make sure that we get that done. Okay, good question. And then obviously next weekend, guys, you do also have a 4-day weekend because there's no school on that Friday and Monday for you guys. Okay, so again, take this weekend to make sure you're all caught up and ready for the end of the quarter. And then Friday through Monday, make sure you wind down from the end of that quarter. Really quick question, what time do courses close on Thursday the 24th? Do we know what time do courses close on Thursday the 24th? 11:59 is actually more accurate. Yeah, 12 a.m. is technically the next day, so courses are completely over by that time. So yeah, midnight is really your benchmark. 11:59 technically is the last minute of the quarter. That being said, guys, do you think you should wait until like the last hour to turn things in? Do you think you should wait that long to turn things in? No, here's the problem, guys. K-12 has a really big tendency of crashing during the last hour of the quarter. So if you're waiting so long to get things turned in by that time, you might not be able to turn things in because the computer just doesn't work. And I can't accept it otherwise. Like, you can't tell me the next day, oh, my computer wasn't working. Can you still accept my work? Just because I don't know if that's true. Right? So even if you have timestamps, even if you have pictures, I still don't know if that's actually true that you were trying to submit something. And so I just can't accept that work, right? So there's no extensions if you wait till the last minute and the computer breaks, the internet breaks, okay? Give me a LOL if you understand. LOL if you understand. Again, just make sure, get everything in. Don't wait till the last hour, okay? Especially don't wait till the last minute, okay? Mostly for your sake, because again, the system does tend to crash a lot. Cool. All right, guys. So today is the multiple choice section of your final assessment part 1. It's 23 questions. Part 2, again, we will be doing on Tuesday after the 3-day weekend. And Tuesday is just 3 short answer questions. So Tuesday, the questions are a little bit harder, but there's actually only 3 of them. They're super easy. We'll be able to get them done in class, no problem. However, today, the multiple choice section is actually pretty long, and it's still super easy, but there's just a lot of questions. So in order to be able to help you guys and make sure that you get as much time as possible to do the exam, what I have is I have a recording that I've done of all of the questions and answers. Okay, obviously I don't explicitly say the answer is blank, right? But on the slide where I go over the question, the answer is there. Smiley faces if you understand. Again, I try to make your life as simple as possible, but I'm not doing the work for you. Okay, you have to meet me halfway. Actually, just meet me like 3/4 of the way. 3/4 of the way to make sure that you are successful. Okay, so you're going to watch the recording and watch the recording, work on the questions. It goes over every answer on the exam. You'll notice that the questions aren't in order, so you will need to do a little bit of scrolling up and down to make sure that you get it done. But again, just follow it through and it will make sense. Okay. So sorry, I just want to make sure I have the exam pasted up here so that you guys have that. Here we go. So here's the link to the exam up here at the top. Questions won't be in order, but just go through it, okay? Now here's the thing. This way you're able to actually go through at your own pace, pausing as you need to, answering at your own pace, doing what you need to, and it's not going to be super rushed and you won't feel like you're missing out on things. Okay, give me a thumbs up if that feels like that's good for you, right? If you like the ability to pause and do things at your own pace, lovely. Okay, so you can go a little faster if you want, a little slower if you want. Do what you got to do, okay? That being said, guys, oh, sorry. Let me get you your attendance ticket. Stephen, here we go. So that being said, if you do need help, I will be available in the chat box. I'm going to technically turn off the public chat. So when you chat, it'll automatically go to a private chat to me. So that way we can have a conversation. You don't need to be embarrassed. Ask any question you want. It won't seem stupid. No one else is going to make fun of you for questions because they won't actually be able to see your chat box. Okay. So you'll watch the recording. If you get stuck at any point, please, please, please let me know in the chat box and I can go over with you in the chat box. Okay. Go ahead and give me a green check if that makes sense. Green check if that makes sense. Because again, I want to give you the most tools and the opportunity to ask questions if needed. Okay? So that's all you need to know. This brought you to the exam. Sorry, let me double check here. Did that link on the board give you guys the exam? It should, right? 758369984. Yeah, that's correct, right? Okay, yeah, gotcha, cool. Okay, so I'm going to go ahead, I'm going to put the recording up on the board. I'm also going to send you a direct link to the recording. I will give you the last word at 12:40, so please don't ask me for the last word before then because you need to wait until 12:40. I'll put a timer on the board. But until then, this entire time is yours to be working. Stay in the classroom, keep working. If you have questions, you are in the chat. Last time, smiley faces if you understand what we're doing, confusion faces if you are confused about any of that. Awesome, guys. Okay, so let me go ahead and I'm going to grab, and grab the recording here. All right, I'm going to turn off my video, post this in the board for you guys. So let me go ahead and put this up for you. And then it will also be in the chat box. Thanks, guys. Get to work. Again, I'll see you back at 12:40. Ongoing. Okay, so today we're looking at lesson 11.01. So we are talking about matter, right? So we're looking at atoms, elements, compounds, chemical reactions. We're looking at different states. We're looking at mixtures, organic and inorganic. So we're going over a lot of information today. All right, so first things first, let's go ahead, get your exam open. All right, so I'm going to go ahead, send you the link to your exam. So you need to open up your exam, and we are working on question number 4. We are not going in order. So you'll notice that by the end, you'll have all 23 questions completed, but we are not going in order. We're starting with question number 4, for example, okay? So remember, matter, this is everything around you, water, soil, air, sun, people. It's made of atoms, and it has mass, which we can think of as weight. Now, if you break down matter to its smallest building block, that is what's called the atom. And an atom is made up of 3 parts, right? Those positive protons, neutral neutrons, and the electrons. Hi, Anissa, please open up your exam. An element is going to be a chemical substance that you cannot break down into another chemical substance. So for example, gold, right? If we took a block of gold and we started to divide it in half, smaller and smaller and smaller, and kept on trying to divide it, eventually you would get down to just a single one of these circles, which is an atom of gold, and you cannot split the atom of gold anymore. If we tried to split it anymore, you would get an explosion, and it would no longer be gold. Okay, so it's the smallest thing that can still be considered that that element. Okay, all right, go ahead, answer question number 4. Give me a green check when you have that saved. Again, no answers in the chat box, please. No questions in the chat box. Christian, we are not going in order, so you need to go to question number 4. Yep, no problem. 15 more seconds. Yep. All right, need green checks from Alex, Brandon, Christian, Rosalinda. Green checks if you are all set. You've either answered it or you've taken a picture. Excellent. Alex, still waiting on you? Thank you. Perfect, guys. All right. Okay, so now go to question number 8. Again, we are not going in order, so go to question number 8. So question number 8, talking about compounds. Again, we just talked about elements. They're a single type of atom, like gold. And there are 90 of them that are found naturally on Earth, like gold, silver, hydrogen, helium, lead, mercury, etc., etc. Other ones, however, usually the larger ones, need to be synthesized in a lab because they are not as stable and they degrade very, very quickly. So when we take 2 elements, or more than 2 elements though, and we begin to chemically combine them, those are what compounds are. So for example, the 2 elements hydrogen and oxygen can be combined into different compounds, such as water, which is 2 hydrogens, 1 oxygen, or hydrogen peroxide, which is 2 hydrogens, 2 oxygens, right? These are still considered pure substances because they are chemically bonded, so you can't physically separate them, like how we can physically separate salt and water with evaporation, right? The only way you could separate them is through a chemical reaction. So things are pure unless they can be separated through a physical, by physical means. There are about 18 million compounds. They can be as small as water or as large as something like DNA, which is in your cells and makes you who you are. Okay, please answer question number 8. You have 30 seconds. Green checks when you have that saved or you've taken a picture. Work quickly, please. All right, we are waiting on a green check from Anthony, from Brennan, from CJ, and Rosalinda. Green checks, please, if you have number 8 saved. Maxine, make sure you open up your exam, please. All right. CJ, still waiting on you. Make sure I get a green check for number 8. Hi, Terrell, please make sure you open up your exam. All right, let's keep on going. Okay, so now go back to question number 5. We're going to talk about physical versus chemical properties. Remember, physical properties, they do not change the chemical makeup of matter. So how something smells, whether or not it's frozen, boiling, melting, how viscous it is, its density, whether we measure these or try to change these properties, it does not change the actual identity of the substance. So for example, ice, which is just frozen water, is still water. Right? Chemically, it is still made up of the exact same molecules. Those molecules are just kind of in a different structure. Now, chemical properties, on the other hand, can actually change the chemical makeup of matter. So, for example, something can react with water, something can combust, right? So, for example, hydrogen can ignite and explode, which changes it. Zinc can react with hydrogen peroxide, which changes it, and changes it into hydrogen gas, right? So again, if you end with something different, that means that you have changed its chemical properties. And another example would be acids and bases can actually react together to neutralize each other's properties, right? So these are example of chemical properties. Physical properties, again, are not going to change the actual identity of the item. Okay, please answer number 5. Give me a green check when you have number 5 saved. You have 30 seconds. Ready, set, go. Okay, waiting on a green check from Brandon, Brennan, Christian, Rosalinda, and Terrell. Green checks if you have number 5 saved, please. Brennan, Rosalinda, Terrell. All right, perfect. Thank you guys. All right. So question number 2, I'm going to finish it on the next slide, so don't answer it quite yet. But remember, the scientific method, this is the pattern that we use in order to investigate the world around us. This is the pattern that we have been using the entire quarter every time we have done a lab report, right? So in our labs, we have been making observations, asking questions, forming a hypothesis. Using our hypothesis, we are able to design and perform an experiment. From that experiment, we gather and analyze data. Based on our data, we're able to draw conclusions, which our conclusion can be either we've disproven our hypothesis, in which case we need to go back, change our hypothesis, and do this all over again, or we support our hypothesis and we can go ahead and communicate our results to the larger scientific community. So for example, remember, if we have an observation that honey seems to flow faster from a bottle when microwaved, the question would be, does honey flow faster or slower at different temperatures? And then we can make a hypothesis, which is an educated guess or a possible answer to that question, right? So for example, in this situation, right, what would be the if statement, right? If honey is hot or cold. So let's say, for example, if honey is hot, do you guys think it would flow faster or slower? So if honey is hot, then what? If honey is hot, then what? Do you think it'll flow faster or slower? Yeah, exactly. It's going to flow faster, right? So that would be our hypothesis. And based on this, we would design an experiment to determine if this is actually true, right? So here again is our hypothesis. So when we design our experiment, we need to figure out what the independent variable is, which is what we're changing at the start of it, and what the dependent variable is, which is what we are measuring at the end of this, right? So the beginning of our hypothesis right here, this tells us the independent variable, what we're changing at the beginning, and the end at the of the hypothesis tells us the dependent variable, which is what we're measuring at the end of the experiment. So in this case, what would be the independent variable? Take a look at the start of our hypothesis. What's going to be the independent variable? What are we messing with at the beginning of the experiment? What are we changing at the beginning of the experiment? Yeah, the heat, or the other way to say that would be what? Temperature, right? Yeah, the temperature of the honey, exactly. And then the effect would be what? What would be the the dependent variable? What would be the dependent variable? Yeah, it's not, yeah, so distance, right? So the distance that the honey flowed, right? So how far we got the honey to flow. Okay, so that's an experiment that you guys did at the beginning of the quarter, okay? So go ahead, based on this, please answer question number 2. Give me a green check when you have that saved. You have 30 seconds. Ready, set, go. And let me copy and paste number 2 into the chat box. All right, Anissa, Anthony, CJ, green checks, please, if you have number 2 saved. Awesome, thank you, CJ, just waiting on you. Green checks if you have number 2 saved. About 5 more seconds, and then I'll go ahead and move you if I don't get a response. All right, moving you now. Okay, so now let's move into a different gear. All right, so let's talk about the phases of matter, right? There is solid, liquid, and gas. Now, gases, we spent an entire unit actually on gases themselves because gases are super interesting. They actually don't have a definite volume. Okay, they don't have a definite volume, which means that instead, based on the temperature or the pressure of what's going on around them, this is going to change their volume. So similar to liquids, gases do take the shape of their container. So you'll notice a liquid spreads out to take the shape of its container. But unlike liquids, they also take up the volume of the container. So they don't just stay at the bottom of the container, they actually go and spread out to every single edge of the container. Okay, so they will take on the volume of their entire container. Which means that if you open the container, they'll just continue to spread out further and further because then they're no longer enclosed. So basically their idea is try to get as far away from each other as they possibly can. So that being said, molecules do have a lot of space between them, and they move a lot because they have really high thermal or heat energy, right? That's how they are able to spread out so far, is because they have so much energy. Okay, go ahead and answer question number 14 in the chat box. Give me a green check when you have that saved. I will give you 30 seconds. Ready, set, go. All right, need a green check from Anthony, Brennan, Christian, if you have number 14 saved. Awesome, thank you. Okay, so go up to question number 12. So we're talking, let's go back and talk a little bit more about these other states of matter. So remember, the properties of solids, liquids, and gases, it depends on how their molecules are actually moving. So remember that molecules move no matter what state they are in. There's no such thing as a molecule that stays completely still. It's just how fast they're moving. So in solids, for example, they're moving very, very slowly. So they're actually just vibrating in place. And so that's why solids are able to stay in a rigid structure, because those molecules, while they're moving, are not moving very quickly. Liquids, on the other hand, those molecules are free to move. And so, but they still can't move that fast. So they stay close to each other, which is why they're able to move around each other, which is why you can pour a liquid. But the liquid doesn't float away, right? Because those molecules have to stay somewhat close to each other. Gases, on the other hand, gases will float away because those molecules can pull apart completely and actually move around and separate from each other, move around on their own. So remember that this has to do with this idea of energy being absorbed or released. So when we absorb heat, which is endothermic, we're melting or evaporating those molecules because we're making them move so much faster. If, on the other hand, we release heat, which is exothermic, then we would begin to freeze or condense the substance, which makes sense because we're removing energy from those molecules, so they have to slow down. Okay, go ahead and answer question number 12. Give me a green check when you have that saved. You have 30 seconds. You can also take a picture, but I need those green checks. Otherwise, you will be moved to the MIA room. No exceptions. Work quickly. All right, waiting on Anthony, Maxine, Rosalinda. I need your green checks if you have number 12 saved in your exam. Thank you. Anthony, just waiting on you. All right, thank you, everyone. Okay, so question number 10. It might have been that the mic slowed down for a moment, Actus, which then it speeds up to try to catch you up, which makes me sound like a chipmunk. It's a technology thing. Or I was talking to my baby while trying to talk to you guys at the same time. Also possible. Okay, so go back up to question number 10. So remember, freezing and melting, these are opposite processes, right? So freezing is when we go from a liquid to a solid, so liquid water to ice, for example. And here the molecules are slowing down, which means that, again, if we're slowing them down, we're actually getting rid of energy. Right? So those molecules are releasing their energy, the energy is going away from them, and so that's going to be exothermic. So for example, when water freezes solid at 0 degrees Celsius, this is an exothermic process. Melting, on the other hand, is going to be the opposite process, a solid to a liquid. And in this case, so like ice to liquid water, and in this case, we're speeding up the molecules, which means those molecules are absorbing energy. They're getting energy. So if they are absorbing heat energy, that's going to be endothermic. So for example, water melts at temperatures that are higher than 0 degrees Celsius. Okay, go ahead, answer question number 10. Give me a green check when you have that saved. You have 30 seconds. Ready, set, go. All right, waiting on a green check from Anthony and Daniel. Awesome, thank you, Daniel. Anthony, still waiting on you? Green check for number 10, please. All right, 5 more seconds. All right, moving you now. All right, guys, so this idea of melting and vaporizing things, this idea of melting and vaporizing things, this is going to be called the heat of fusion and the heat of vaporization. So this is talking about the amount of heat needed to do these processes. So the heat of fusion is the amount of heat needed to melt 1 gram of solid to liquid. So like 1 gram of ice to liquid water. Now, in this process, when we are using the heat of fusion, the heat is only going to making the molecules separate from each other. So it's only causing the melting to happen, but the temperature is not going to actually change because it does not make the molecules move faster until all of the melting is completed. So once all the melting is completed, then the molecules can begin to move faster, which will then increase the temperature. Okay? This is also the same amount of heat that the liquid needs to release in order to become solid. So the opposite would also be true. Now, hey guys, sorry about that. Yeah, it definitely kicked me out for quite some time. All right, guys, go ahead, give me green checks though if you have number 13 saved. Thank you guys for sticking around during that little technology faux pas. Doing good. All right, looking good. Oh, Christian, did you have number 13 answered? Looks like everyone else did, so just want to check. All right, perfect. Let's keep on going. Okay, so question number 9. So go back up to question number 9, talking about protons, electrons, and neutrons. Again, we talked about this a moment ago, right? Atoms have 3 parts. Protons, which are positively charged. Remember that these tell you the atom's identity, right? So based on how many protons you have, that is the identity of the atom. We can also call this the atomic number, the number of protons. And protons weigh 1 AMU, so they have mass. Neutrons are neutrally charged, hence why they're called neutrons, neutron, neutral. And these are there to prevent protons from repelling each other, because remember, protons are all positive and like charges want to repel. So these positive protons don't want to be next to each other. The neutrons, though, help separate the protons a little bit to help so that the protons don't repel each other. They also each weigh 1 AMU, so they have mass. Electrons are negatively charged. They are involved in bonding because they're on the outside of our atom, so they're the things that are capable of being close to other atoms to bond. And they almost weigh nothing, so they almost have no mass. They're very, very, very tiny, so they weigh approximately 0 AMUs. Remember, if an atom has equal protons and electrons, it's going to have a neutral charge overall because those charges balance. And remember, the number of protons always has to stay the same because if it changes, the atom also changes. All right, go ahead, answer question number 9. Give me a green check when you have that saved. 30 seconds, ready, set, go. Would you say Jimmy Neutron is positive? Should his name be Jimmy Proton? Yeah, doesn't sound quite as right. All right, waiting on Alex, Anthony, Brennan, CJ, green checks for number 9, please. Awesome, let's keep going. Okay, so number 15, again, we just talked about this, right? The identity of an element is based on its number of protons, right, which are those positively charged particles. So for example, if you know an atom has 2 protons, then you always know that it is helium. Okay, if the number of protons changes though, it's no longer helium, its identity has changed. Again, those neutrons are used to prevent the protons from repelling. Electrons give it bonding properties, but neither of those 2 things, neutrons or electrons, define its identity. Only protons define identity. So when we look at the periodic table, or we look at one of the boxes on the periodic table, we can see elements have a name, like oxygen, they have a symbol, like O, and they have an atomic number, like 8. And that atomic number, 8, tells you the number of protons. So oxygen has an atomic number of 8, which means it also has 8 protons. That is its identity. Okay, question number 15. Go ahead, answer that in the chat box. Green checks, sorry, answer that in the exam. Question number 15, 30 seconds to get that answer. Give me a green check when you have number 15 saved in your exam. Go, go, go. All right, need green checks from Anthony, Brennan, Christian, and Rosalinda. Make sure you get your green checks for number 15. Awesome, perfect, thank you guys. Okay, so question number 16, so this one's actually in order right afterwards. So elements and isotopes. Remember, different number of protons, completely different element. However, you can actually change the number of neutrons without changing its identity, right? So you can change the amount of neutrons, and all that's going to do is it's going to change the atomic mass of the atom, right? And these are what are called isotopes. So when we have a different amount of neutrons, that's going to cause a different amount of atomic mass, and that is going to be a variation. So that's what's called an isotope. So for example, here are 3 isotopes of hydrogen. They're all hydrogen because they all have the same number of protons, but they have different masses because they have different neutrons, right? Protium, which is the isotope of hydrogen that has 0 neutrons, deuterium, which is the isotope of hydrogen that has 1 neutron, and tritium, which is the isotope of hydrogen that has 2 hydrogens. Okay, the only thing that you're seeing change though is the atomic mass, right? Atomic mass of 1, atomic mass of 2, atomic mass of 3. All right, so that is an isotope. Go ahead and answer question number 16. Give me a green check when you have number 16 saved. 30 seconds. All right, CJ, Lenice, Rosalinda, green checks for number 16, please. Looking good. Thank you, Lenice. CJ, thank you, Rosalinda. CJ, make sure you get your green check for number 16, please. I know, that does seem quite clever, doesn't it, Actus? All right, let's keep on going. Okay, so this one's going to answer question number 1 and 11, not on this page yet, though. We're going to keep on going. So you can look at them right now, but don't answer them quite yet. Okay, so remember that atoms, all atoms on the periodic table, they want to have a stable configuration. And the way that they can have a stable configuration is if their outer shell is completely full, right? So for example, in fluorine, its outer shell could hold up to 8 electrons, but it currently only has 7, right? You can see that here, 1, 2, 3, 4, 5, 6, 7. Again, ignoring everything in the inside. We're only looking at the outside. Only looking at the outside. Which means that right here, this is a spot where we could have another electron in order to fill this outer ring up to make it stable. So fluorine just needs 1 more electron in order to be stable, which we can get while it's bonding. We are going to do both number 1 and number 11, Christian, in a couple slides, okay? So remember though that if it's a small atom, it actually only needs 2 electrons, but all the bigger atoms are going to need 8 electrons on that outer shell, okay? So, but most atoms need 8 electrons on the outer shell to be stable. Now, again, the way that they get these extra these extra electrons, or the way that they fill up their shell, there are a couple of ways. So they do this through bonding. So one type of bond is called the covalent bond, where we actually share valence electrons between atoms. And this happens between nonmetals, right? So you can see the nonmetals highlighted on the periodic table, like hydrogen, boron, carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, chlorine, so on and so forth, okay? Now, the reason that these happen, that these molecules are formed, is because nonmetals are not strong enough to completely remove an electron from each other. So they have to share those electrons, which is why it's called covalent bonding, okay? So, again, the whole reason that we do this is because we're trying to fill those shells. So by gaining, losing, or sharing electrons, we can fill those shells, which is why atoms want to bond in the first place. So for example, water is a great example of this. Remember, hydrogens, they're tiny. So hydrogens would like to have actually 1, 2 electrons on their shells. However, you can see right here that currently hydrogen is missing its second one, right? It doesn't have a second one right here. Okay, same thing with oxygen. Oxygen can have 8, right? So it has 6 right now. It's missing 2 though. So it's missing 1 right here and 1 right here. And so what they're going to do is they're going to actually share electrons with each other. So by sharing these electrons, they can actually complete their shells. So what we'll see happen is, sorry, let me delete that for a moment. What we'll see happen is hydrogen will share its 1 electron with oxygen, and this oxygen will share 1 of its electrons with the first hydrogen. The second hydrogen will share its electron with oxygen, and oxygen will share 1 of its electrons with the second hydrogen. And so they end up creating a pair and sharing together. And so now from hydrogen's perspective, hydrogen now sees 2 electrons and is now happy. Same with this hydrogen. From its perspective, it now sees 2 electrons and is happy. And oxygen, from its perspective, now on its ring, it has 8 electrons, and so now oxygen is happy. So through bonding into water, this creates a very, very stable molecule because now the atoms are happy. Okay, so go ahead and answer question number 1 first. Okay, question number 1 first. And then go ahead and answer question number 11. Question number 11 as well. Okay, I'm going to go ahead and give you a little bit longer to work on this one. So I'm going to give you 45 seconds to get this one done just because there's 2 questions. But I still need green checks when you have both of them saved. No problem, Brennan. So take a look at oxygen. Again, look at how many hydrogens it's bonding with, right? So that's question number 1. So number 1 is asking how many hydrogens does oxygen want to bond with? And then question number 11 is asking about the original valence electrons of hydrogen and oxygen, right? So you want to count up the number of electrons on the outside of their rings, okay? The outermost rings, outermost rings. Okay, does that make sense, Brendan? Awesome. Perfect. Okay, waiting on Alex, Anthony, Christian. Green checks, please, for number 1 and number 11. Excellent. Got everybody 100%. Awesome. Okay, scroll all the way down to number 20. Let's talk about metallic bonds while we're talking about bonds. Remember, metals are kind of unique because metals have this grid or matrix of positive metal ions. So you can see they're all kind of lined up here. But their electrons can actually flow freely throughout this grid. So you can see negative electrons are actually flowing around or acting like a sea of electrons around our grid here. Now, because of this sea of electrons and these electrons that can move very easily, this gives us the unique properties of metals, which is that they have these charges, these electrons, that can conduct electricity and heat, right? So remember, moving electrons, those are moving charges, which is just what electricity is, right? That's where the word electricity comes from, electron, electricity. It can also make heat move really well because those electrons can move from one side to the other side very quickly, right? So they can carry heat from one side to another side. This also is why some metals are magnetic, because in some metals, those electrons are actually all spinning in the same direction, and that makes a metal magnetic. Okay, go ahead and answer to question number 20. You have 30 seconds. Ready, set, go. Green checks when you have it saved. Yes, exactly, Christian. All right, need green checks from Brandon, Christian, CJ, and Rosalinda. Green checks for number 20. Thank you. All right, so right after that, let's talk about ionic bonds. So remember, ionic bonds are when we have an attraction between a cation and an anion. Remember, cations are positively charged ions. Anions are negatively charged anions. And the reason they're attracted to each other is, again, because opposites attract. Positives are attracted to negatives. So atoms, again, their entire goal is to fill up their shells with all of their valence electrons that they need, those 8 valence electrons. So atoms are going to form cations and anions so that they can have complete shells. Our example here is sodium. We can see sodium right here. Only has 1 valence electron, and really it doesn't want this electron. It wants to get rid of it so that it can have a full shell, right? Because you can see the shell right below it is completely filled already. So what it's going to do is it's going to take that electron, it's going to donate it to chlorine, and that's going to make sodium lose an electron, which will make it positive, right? If you lose negativity, you become positive. So now sodium's positive, it's a cation. Chlorine, on the other hand, is going to get that electron, so it's getting a negative electron, which is going to make chlorine more negative and make it an anion. And now you can see chlorine will actually be happy, right? It had 7 valence electrons, it just needed 1 more, so it gets that 1 more from sodium. And so now chlorine is negatively charged. Wow, that's a gigantic negative. And because we have a positive and a negative next to each other, they are now extremely attracted to each other. So they bond together and create sodium chloride, otherwise known as table salt. All right, this is just regular old table salt. All right, please answer question number 21. Give me a green check when you have that saved. You have 30 seconds. Ready, set, go. Excellent. CJ, Daniel, Maxine, just waiting on you 3. Green checks for number 21. Thank you, Daniel. CJ, Maxine, make sure I get your green checks. All right, I'm going to keep on moving, guys, but make sure I get your green checks. If I don't get them for the next question, I'll go ahead and move you to the MIA room. All right, question number 23. So metals versus nonmetals. Again, what we just saw on the previous slide is metals like sodium, they only have a few valence electrons, so it's easy for them to lose those electrons. So they will become more positive, right? They're losing electrons, losing negativity. Electrons are negative, so they're losing negative electrons, which makes them more positive, right? They turn into cations. So for example, group 1 elements, hydrogen, lithium, sodium, potassium, they all have one valence electron, so they all lose that one valence. They all become positively one charged. Nonmetals, on the other hand, like chlorine, which we saw on the previous page, they already have most of their valence electrons. They just need to get a couple more, so they easily do that. And so by gaining negative electrons, they become more negative. So they become our anions, all right? And that's going to help fill up their shells like fluorine, chlorine, bromine. They'll get one more electron and become negatively one charged. Okay, answer number 23. Give me a green check when you have that saved. Ready, set, go. Okay, green checks, Anthony, Daniel, Mexi, Rosalinda, please. Green checks for number 23. Thank you, Anthony. Thank you, Daniel, still need yours. Maxine, still need yours. Thank you, Rosalinda. Green checks for number 23, please. All right. Okay, so all the way back up to question number 7. Another type of bonding is hydrogen bonding. Remember, this is when we have separate molecules that each contain hydrogen. They are going to be attracted to each other, right? And the reason for this is because for one side of the molecule, that hydrogen is going to be slightly positive. For the other side of the molecule, that's going to be slightly negative. So when you have two molecules together, each side with a positive and a negative side, their opposite sides will be attracted to each other. So for example, the hydrogen of one water will be attracted to the oxygen of another water, and this is going to make water itself stronger because water is literally attracted to itself, right? This is again why we have such cool surface tension from water. So if you put a bunch of drops on a penny, you can actually get way more drops of water on there than you would expect because water is actually pulling in on itself to prevent itself from falling off the penny. Your water, Alex. I like it. All right, so the cool part about this, I know, water is very self-absorbed. I like that one. That one's good, Axis. So this is actually why water has a really unique property in that its frozen state actually floats. So most substances like iron, the solid state is actually denser than the liquid or gaseous state, which means the solid will sink. But water is different because water actually floats when it's frozen, and this is because of the hydrogen bonding. So normally the hydrogen bonds, I'm sorry, she just stuck her hand in my mouth and then I accidentally bit her. That's what happens when you stick your hand in my mouth while I'm talking. All right, so those hydrogen bonds, usually when they're in liquid water, they're constantly breaking and reforming and sliding past each other. However, when we freeze them, they actually freeze in a specific shape. So those hydrogen bonds actually freeze in a hexagon shape. And so that pushes the molecules far apart. And they're further apart than they are in a liquid, which makes them less dense, lighter, and so it floats. So because of this hydrogen bond, it creates a grid, which makes ice float. Okay? Go ahead and answer question number 7. Give me a green check when you have number 7 saved. Green check when you have number 7 saved. 30 seconds. I didn't mean to, Brennan. Maybe she should just learn not to stick her hand in my mouth. I see, we're siding with the baby. That's probably right. We should probably side with the baby. All right, Brandon, CJ, give me a green check, please. Same with you, Rosalind, green checks for number 7. And you have number 7 saved. Perfect. Thank you, Brandon. CJ, waiting on you. Rosalinda, waiting on you. Need your green checks for number 7. Okay, so number 6, right above that. Number 6 talks about solutions. So remember that when we have a solution, this is a homogeneous or uniform mixture of 2 or more substances in a single phase, right? So this is going to consist of this will consist of a solute and a solvent, right? So for example, brass is going to be copper and zinc, soda is sugar, water, and CO2 gas, air is a bunch of various gases, right? So there are lots and lots of different types of solutions besides just water and sugar or water and salt, okay? So the solute, that's the substance that we have the smallest amount of, and that's what's getting dissolved, right? So that would be like salt and water, okay? Now solvent is going to be what we have more of, so that would be the water, and this is what's actually doing all of the dissolving, okay? So this, for example, would be water, which would make sense. Water is actually the universal solvent, not that it can dissolve everything, but it can dissolve most things, okay? Go ahead, please answer question number 6. Give me a green check when you have number 6 saved. Yes, exactly, the ocean. All right, green checks when you have number 6 saved. You have 30 seconds. Ready, set, go. Where did that come from, Brennan? Oh dear. Yeah, so if the entire ocean dried up, yes, we would be left with a huge mountain of salt. This is actually why have you heard of the Dead Sea, Actus? The Dead Sea filled with it's extremely salty water. Yeah, so it's extremely salty water, and the reason for this is because the Dead Sea has no natural inlets or outlets, or sorry, has no natural outlets. Yeah, anyways, there's not a constant flow of water in the Dead Sea. So what's happening is because there's not like a constant flow of water, as water evaporates into the atmosphere, it begins to leave more and more salt into the Dead Sea. So over time, the Dead Sea is actually going to become saltier and saltier and saltier. Okay, awesome. Green checks, got all of them. Let's keep on going.
Okay, so we're thinking about solutions and the solvent and the solutes. How much solute will dissolve into a solvent is called solubility. And this is measured in grams per 100 grams of water. Okay, and this is affected by temperature and pressure. So if you increase the temperature of the solid solution, you're going to increase that solubility. So for example, you know, if you were to put sugar in your tea, and you stir it around, if you put sugar in iced tea, that solubility isn't going to be as great as it would be if you have hot tea. So that's why if you put that way, if you ever want to put sugar in anything and have it and have it mix better, you're going to increase the temperature. And also, if you increase the pressure, that's also going to increase the solubility in gas. And so now the rate of solution, that is how quickly it dissolves. And so that is why you stir things around. If you have smaller solutes or smaller granules that have a larger surface area, that's also going to increase the rate of solution. So again, this is why if you are stirring sugar into some tea, it's going to increase the rate. If you're increasing that temperature, it's also going to increase the rate. So answering question number 17, you have 30 seconds to answer, to save this in your assessment. So go ahead and put that in right there, and you have 30 seconds, 13 more seconds. Okay, good. So Riley and Robert, waiting on you, and Yvonne. And Kobe. All right. Moving on, guys.
Okay, so remember that we talked about acids and bases. If we have a really strong acid like hydrochloric acid, which has a pH of 2, or a very strong base like ammonium hydroxide, which has a pH of 12, alone, both of these are very corrosive because remember, when we have extremes on the pH scale, they're going to be dangerous. However, if we mix the opposites, acid and base, this creates a neutralization reaction. They neutralize each other. They no longer have those extreme pHs. Their pHs get closer to neutral. And so they turn into things that are not dangerous, like ammonium chloride, which is a neutral salt, which is not corrosive. And we can see that reaction right here. You have 30 seconds. Give me a green check when you have number 22 saved. Sorry, I accidentally erased some of those green checks. So if you already gave me green check, give it to me again, please. Christine, Eddie, Emily, Kobe, Madeline, Pritanya, Kayvon, Sabrina. Excellent. Okay, so we talked about organic on Wednesday. This was our most recent lesson, so this should be super familiar. Remember, organic means that things are carbon-based. Organic compounds are compounds that are structured around the atom carbon, and those include things that are have ever lived or that are living. Inorganic compounds, on the other hand, aren't centered around carbon, and they don't necessarily come from living organisms. So, for example, silicon dioxide, which is quartz, water, and hydrochloric acid. Really quickly, this is your third main idea in your notes. Give me a green check when you have that saved. 15 seconds. This should be quick. Excellent. Waiting on Eddie. Oh, thank you, Eddie. Emily, Kobe, Jeremy, Madison, Robert, Riley, Serena. Awesome. And 5, 4, 3, 2, 1. Okay, so macromolecules, we're talking about in living organisms, some organic molecules. There are 4 classes of them called macromolecules, and again, these are organic molecules that occur naturally. Now, macromolecules are what we call polymers, because remember, they're made up of repeating units called monomers. So anytime you have a molecule that repeats over and over and over again, that creates what's called a polymer. And so the 4 classes are carbohydrates, lipids, proteins, and nucleic acids. Specifically, carbohydrates, these are found in starchy or sugar-filled foods. And remember, the monomer that makes up a carbohydrate is a simple sugar called a monosaccharide. It literally means single sugar. Mono meaning single, saccharide meaning sugar. So that's our monomer. If we link 2 of those together, it makes a disaccharide. If we get a whole bunch of those single sugars and link them together, that equals a polysaccharide. So again, don't forget carbohydrates. These are what give us energy. You have 30 seconds. Give me a green check when you have number 3 saved. And let's go ahead. I'll paste that in there for you. Here is number 3. Excellent. About 15 seconds left. Alexis, Eddie, Emily, Kobe, Riley, and Vanessa. And 5, 4, 3, 2, 1. Okay, so organic compounds, they can come in many different shapes. Again, they're based around carbon, and so they have a few basic structures. They can come as chains, which we can see right here, some carbons and some hydrogens in a chain. We can see some rings, those carbons in black, with the hydrogens in white attached, but they're centered in a circle or a ring, and they can also branch off of each other. So we can see right here we've got a chain of 3 carbons with 1 carbon branching off of it. Now all of these molecules that you're seeing with the black carbons and the white hydrogens, those are what are called hydrocarbons, which it says it in the name, they only contain carbon, which is the carbon part of hydrocarbon, and hydrogen, which is the hydro part of hydrocarbon. So they only contain those 2 things, and again, they're formed by stacking the same molecule. So for example, we can see methane, when it's stacked with 2 methanes, that becomes ethane, 3 methanes become propane, and 4 methanes become butane. Okay, go ahead and give me a green check when you have number 18 saved. Number 18 saved. You have 30 seconds. Waiting on Eddie, Kobe, Madeline, and Robert. 10 seconds left. And 5, 4, 3. Oh, we got everyone. Awesome. Okay, so another type of organic molecule is plastic, which plastic doesn't seem like it comes from living things, but remember they are formed from fossil fuels, which are basically dead plants and dead animals and dead dinosaurs. Plastics are polymers because they are made up of many repeating units called monomers. Okay, so they are polymers. That's a part of question number 19. That is a true statement. So for example, polyethylene is made up of many linked ethylenes. Polypropylene is made up of many propylenes. Polystyrene is made up of many styrenes. So they are polymers. They are also, again, also considered organic because they are created from organic material. Fossil fuels are once living organisms. And again, they are polymers. They're made up of many linked items together. Go ahead and give me a green check when you have number 19 saved. 10 seconds left, waiting on Riley and Kobe. Awesome. All right, guys, how are we feeling about that? I'll open up the chat again. Tell me in the chat box, how'd you feel about that? Easy, hard, confusing, understandable? Good. Okay. Yeah, I was hoping it's not too scary, right? Oh yeah, no, you probably won't be done. I'm gonna send you the links again. So you probably still have a few questions left to do. That's totally fine. I'll send you the links once more. Just open it up on your computer. Smiley faces if that makes sense. Okay, yeah, yeah. No, I know for sure. It's a little bit longer than we actually have in class. Awesome, guys. So yeah, get those links, grab those right there. Yeah, Haley, right here for you. So there's the Safe Share version and the YouTube version. Okay, so grab those, open it up on your actual computer so that you have it, because obviously I'm going to close this class. But open that up, that way you can finish it. If you miss it for some reason, it'll be in the 11A recording as well. You don't need both versions, just whichever one works for you. The Safe Share one usually is less distracting, but sometimes the YouTube one works better for people. That's why I put both of them. Okay? Yeah, it's the same video, just different formats. Cool. So grab those links or whichever link you need, and that will take you through the rest of that, and that way you don't have to worry about it. And then as long as you guys don't have any questions, as long as you don't have any questions, you will be all set to go. So let me go ahead and grab you your last word. Here you go, guys. Thank you so much for being here. I will see you on Monday for our last part of the exam. Make sure, or sorry, Tuesday. See you on Tuesday. Have a great 3-day weekend. Bye, everyone. Thanks so much for being here. Go ahead and log out, and I'll see you all later. Bye, guys. You too. Bye, Haley.